Hey guys, today we're going to focus on the ear and sound transduction, and really we're going to be more focused on the sound transduction portion, and we'll just go over the parts of the ear that are involved with that. So we've got this sound wave coming through the air, and it's going to enter your ear, the outer ear that you can see, or the external ear, and it's going to hit what's called the tympanic membrane. And that's what's more commonly referred to as your eardrum. Let's draw that a little thinner here. When these sound waves hit this tympanic membrane, it's going to transfer those vibrations over into three bones called ossicles. So bones of the ears are ossicles. Whoa, oh. Ossicles. Now those are the three smallest bones in your body. And the first one is the malleus, and it's called the malleus because it acts as a mallet, and so more or less resembles a mallet. So instead of actually trying to draw the bone, I'm just going to draw a mallet. So we've got our malleus right here. And when those vibrations vibrate the malleus, that's going to in turn transfer those vibrations to another bone. It's the second bone of the ear ossicles, and that's called the incus. The incus, and you can think of this as the anvil. And it sort of looks like a tooth with two roots. I haven't been very good at drawing this in practice, so we're just going to go with this for now. And when that mallet strikes that anvil, it's going to vibrate a third bone, and that bone is called the stapes. So let's see, let me label these really quick. Malleus, I think that's how I spell it. This is the incus, and then we have the stapes right here. And this people most often refer to as the stirrup bone. It kind of looks like a stirrup. And this portion of your ear is going to comprise the middle ear. This is the middle ear. Middle ear. And like I said, out here, before you hit the tympanic membrane, is the external ear. And that's going to be comprised of the ear that you can see, and then that external acoustic meatus going into there. External ear. So once those vibrations reach the stapes here, or the stirrup, and we're entering the inner ear. So let's see. So the tympanic membrane, this is important to go over real quick. The tympanic membrane is the entire surface area that is what's connecting the middle ear to the inner ear. So any sound transduction that enters the middle ear is entering through the vibrations of this tympanic membrane. And you can kind of think of that as like the head of a drum, a snare drum. So those vibrations then reach this stapes, which is then connected to the oval window. And the oval window sits right in this footprint of the stapes. So I'm just going to draw something small right here, but really that stapes covers the oval window, and it's just that footprint. And that oval window is the beginning of the inner ear. And all the oval window is the only sound transduction surface area between the middle ear and the inner ear. So we'll draw this up here. This is kind of just the barrier here between the middle ear and the inner ear. So from there we're going into the cochlea, which looks like a snail shell. And I'm going to draw it unwound like your book does in figure 1621, because it's kind of easier to see that way. So we'll begin Just drawing it out here. Loop up this way. Come back around. And this would normally be wrapped up, rolled up nice and tight, like a snail shell or a seashell. Like I said, I'm drawing it unraveled like your book does because that it's easier to kind of see that way. Cool. So we have these sound vibrations that enter the inner ear. Just to stay consistent here. Inner ear. And they're going to travel through a fluid that's found right here. There's fluid all throughout here, and inside here as well. But this fluid that the sound travels through first is called the perilymph fluid, or perilymph. And it's found inside of the scala vestibuli. Scala vestibuli. So this area is the scala vestibuli. It's this area right here that's superior to this purple duct that I've drawn, and that's filled with perilymph. So filled with perilymph. So those sound transductions are going to come through here, and they're going to enter the cochlear duct. If they're within the range of hearing, if it's a sound that you can hear with your ear, then it's a vibration that's entered the cochlear duct. So that vibration is going to enter right here, I believe, and enter into the cochlear duct. Cochlear duct. And this cochlear duct is also referred to as the scala media. Cochlear duct equals scala media. Media referring to middle. And that's going to be filled with endolymph. Filled with endolymph. And the distinction between these two fluids is really important because this perilymph is actually continuous with cerebrospinal fluid in your head, whereas the endolymph at no point is continuous with the cerebrospinal fluid. So it's two different fluids that fill the scala vestibuli and the cochlear duct. So once you're inside the cochlear duct or scala media, that's when these sound vibrations interact with hair cells which vibrate, and those vibrations are going to cause different amounts of neurotransmitters to be released, and the nerve that's innervating that to pick that up, and that's how these sounds are created into something that you can understand, that your brain can understand. So it's going to travel through the inside of here, and be transmitted along these hair cells that are in the basal membrane here of the cochlear duct. So right here and right here, all along the basal membrane, you have hair cells that are transducing these sound vibrations. So what happens to the rest of the sound that doesn't get picked up by the cochlear duct? So that's going to travel around and miss the cochlear duct and travel across something called the helicotrema. The helicotrema. Helicotrema. And once it passes that, it's going to enter the scala tympani. So on this side of the cochlear duct, we have the scala tympani. Or tympani, but I'm going to go with tympani. Scala tympani. And that is filled also with perilymph. So we have the scala vestibuli and the scala tympani filled with perilymph. And while it's traveling through here, it's going to wind up at the round window. The round window right here. Ish. It's actually going to be within the cochlea here, so draw right there. And this is essentially an overflow valve, you can think of it. So if these sound waves aren't picked up by these hair cells and aren't absorbed by the hair cells, then they need somewhere to go, or else you get this continuing interference, either constructive or destructive interference within your cochlea, and it would change the sound that you hear. And so you need some sort of exit strategy for these sound waves that don't get absorbed. So you can think of this, like I said, as an overflow valve for the cochlea, for the sound waves that aren't absorbed. Round window. And that's going to be an opening back into the middle ear, and back where it can be released somewhere where it's not going to cause interference. So I think that's pretty much covered what we're trying to go over today. We've got the external ear, which is the ear that you can see, and it's going to vibrate the tympanic membrane through a series of ossicles, which I should mention creates an amplification effect, something like 1 to 20 or 20 to 1 amplification between what you see, what the vibrations that are felt by the tympanic membrane and the vibrations that travel through the oval window, since this is such a larger surface area than here. So we have these ossicles that are going to amplify the sound and travel into the cochlea in either the cochlear duct or the scala tympani, and then out back through the round window. Thanks for watching today, guys, and we'll talk to you again in a few days.